see that. I've started the recording. This is our lecture for Design 320. It's week 13, Tuesday, April 20th, and it's our live meet, and the recording is on. And what we're going to do today is go over our Project 4 requirements, what to do this week, and I'm going to show you a little bit of a sample project. So let's take a look really quickly on the to-do. So we have Project 4. This is week 1 of 3. And the idea is to design for manufacturing. And this week is initial concepts and sketches. So let's take a look. Here's our playlist, which is a little bit empty right now, but it'll fill up. Excuse me. Here are some of those background materials on weldments and things like that. Project requirements, the template. There is work to do on the discussion board. It's the same as last week, but on a different slide. And then submit. So pretty straightforward. And by now, hopefully you're getting the idea of what we mean by do some research and so on and so forth. So let's see if we can figure this out. First, you have to know the project requirements. This is when it says design to a plan or a program or client requirements. This is where you get those, and you should always include them somewhere in your design presentation. So here's the purpose. We're going to try to get you through an entire conceptualization process. And you've done most of it so far, but we really haven't talked yet about how something will be made. And so we're going to do that now. Present your work in a detailed, organized manner. That's part of that organization. And this time you use your individual graphic and rendering styles. I've seen some good experimentation with different things. I've seen some people using very plain black white, some people using lots of colors, some people being very careful to do, 3-on-5. So just kind of look these over and have some good graphic and rendering styles. So you're going to have to do all of the things that you've learned so far. This week is some quick sketching, some primitives, some research, some concept work. And then later on, you're going to add review and analysis. That's next week. And then revision. And then some 2D documentation, which we haven't talked about yet, but we'll do that next week and the week after. So that's the purpose. It's kind of a full scope, a full stack conceptualization. So here's your requirements. Okay. Your subject or the design topic is you pick one of these. You can do outdoor furniture, a gazebo, which might include solar, a fountain, storage, signage, awnings, special light sconce, or ballards. So all of these are applicable to the work that you did so far. This is to be done, okay, on the projects that you've already completed. This is for your commercial renovation. It can be outside, it can be inside. You could design the signage for your area or some awnings for the windows. Those ballards, you could make those light ballards that are outside. You could design some special light sconces for the outside or the inside. Some of these you have special storage areas that you want to deal with. You can design those. Perhaps you'd like a fountain on site. You can design that. Maybe you need a gazebo or some outdoor furniture. So all of those are available to you. Now, the sample I'm going to do for you is not one of these. Oh, you could also do, I guess I could say, special indoor furniture. If you want to do some special indoor furniture, you can. And that's what I'm showing you. So often there's a design theme. And so our design theme is Sustainable California. And you're going to have to think about sustainability and how your design goes with that. Maybe you'll use recycled materials. Maybe you'll do something that looks like a wastebasket. Maybe you'll do something that um, helps the water. Or maybe you just want to make a sign or an awning that seems like it goes with sustainability. This is wide open, but it requires you to think of the word sustainability and identify in your design sustainable. So this goes along with part of our student learning outcomes, right? And we've been doing this all the way along. I am specifying for you how it will be made. You don't get to change this. You can't say I want to cast it or um, make a plastic 3D printed one or make it out of poured concrete. I'm giving you very specific ways that it's going to be made. So you could make it out of a weldment, weld together pieces of plate and tubing. You could bend pieces of plate. You can bolt pieces of plate, I should say, and tubing. Or you can do a combination of those. Now, if you want to, you can ask me and say, okay, that's cool, but I want to do that with wood. And I might let you if you convince me, but you're going to have to meet with me to say you want to do it out of wood. And the wood has to be plywood and basically square. Okay, plywood or square. And you have to show me that you understand how it's going to connect and go together. But if you're into carpentry and cabinetry that's woodworking, I'll let you do that. There's a reason for using metal, by the way. And that is it's very easy to work with and the welding works well, but it's also very easy to sterilize. And when we're talking about sustainable California, to me, I want something that I can clean and wipe down easily without using a lot of chemicals. And most metals are pretty good at that. So once you've got it built, there's something called finish. Okay, what is it? What does the surface look like? So it can be unfinished. You can just get metal or tubing and let it be unfinished, and it looks kind of industrial and raw. You could paint it, and you can paint metal. That's pretty cool. You can anodize it, and if it's steel, there are comparable processes to anodizing that I can tell you about. And when I talk about paint, I'm talking about epoxy coating or Rust-Oleum or one of those electrostatic coatings, something like that. That's done like a place that would paint a car. And then there's also bead blasting, where you just stick the thing in a great big booth and you hit it with sand or beads or garnet and give it a bead blast finish, and it's really kind of cool. And then of course you can always, if you need to, put a varathane or urethane coating on it. So that's the finish. Materials, metal, appropriate to the fastening or connection methods that you're going to use. If it's copper, you can't weld it. You can only bolt it. You can't weld copper together. Okay? You can kind of sweat it together or braze it in certain cases, but in general, if you make it out of copper or something, you can't weld it. And you can weld aluminum, but you better have a good, well-trained welder to do it with aluminum. If it's galvanized steel, you have to blast it first, because when you weld galvanized, it lets off all these toxic fumes that will kill the welder, and we don't want to do that. So you're going to think about the materials a little bit. And then mounting. How is it going to sit on the ground, get affixed to the wall, hang from the ceiling? How are you going to mount this thing? How will that work? And will it be stable? Does it need to be stable? So there's lots to think about here. There's certainly 3 weeks to think about. Now we're doing 3 weeks to get through the concept design. Once you get into the details, the details should all support the concept. Lots of things can change when you get into the detail. Okay? But those are the product requirements. Kind of cool. It's wide open. Lots of things. If you're interior design, there's lots here for you. If you're mechanical design, there's lots here for you. If you're landscape design, there's lots here for you. If you're like what do they call it? The fabric people. There's even stuff to do for you. Okay, especially when we start talking about the awnings and things like that. So this is wide open, except I'm telling you how to build it. So here's the design process. Week 1, you're going to think about the theme, do some research, make some sketches, do some primitive sketches, think about your material, and think about how it's going to fasten. So that's this week. So nothing really finished or solid, but I'd like to see some cool ideas. And remember, from your research, I want to see what other people have done that's kind of like what you've done. Okay, that you've gotten good ideas from. Your background knowledge. Next week, week 2, is really work on the 3D model, present it, have annotations that explain to somebody, and you are going to present it. Okay? You're going to have that opportunity. You're going to present it. So be ready for that. Be ready to explain everything that you thought about and why, and how you chose this, why you chose this, what you did to check on it to make sure it's all good. Okay? And this should all be done enough so that a viewer can analyze your design compared with this. They should be able to know what was the manufacturing method that's intended? How are connections being made? What is the material? What is the finish like? How are you going to mount it? What is it? What it's used for? How does it meet sustainable? Okay, so that will be week 2. And then you'll get some feedback on your presentations, and you'll do a revision and then do some 2D documentation. Not too bad, not too hard. Okay, we got 3 weeks to get all this done yet. And this is really still the conceptual design. I'm not asking for a finished manufacturable design yet. Still conceptual. Okay? Any questions on the the purpose or the product requirements or the design yet? Okay, then let's go ahead and take a look and see what your presentation is going to be like this week. So again, there's all this, and most of you got a link to your source assignments in there. Some of you didn't, and you lost points. Remember, what is the source assignment? It's this, and now you can also add this. This is all the stuff that you were given for this week. So you need to document this. Is this being recorded? I hope so. Hold on. Yes, it is being recorded. So that was a good question. And so this is your what you've been given. And a link to that goes right there. Okay, and many of you did that. So that was good. So now we've got link to the download file for the model. Whatever modeling you've done should be here. Your Google Drive with all of your research images and pictures and your download file. Everything that you've done should go for this project, should go in a folder. And then, of course, your schedule and your deliverables and all of this. Now, present your research on how sheet metal and tubing designs are made. So that's basically present what you learned from here. Okay, so I want a presentation of that. And that doesn't just mean you put the links to the videos. Let me know what you learned. In particular, with how it's going to affect your design. Okay, so this is your first part of your research. The second part of your research is about the product. And you've all done this part so far a few times now, right? But find similar items to your product and point out the parts of it that you're going to want to incorporate or concepts that you're going to incorporate in your design. I like this steel one because it's easy to clean. I like this one that's made out of styrofoam because it's very light. I like this one because it's this kind of weird shape and bent metal because it looks very futuristic, and to sustain California will need to be futuristic. So go ahead and do that. And I'm going to tell you, start out simple. You believe it or not, it sounds like 3 weeks is a long time to get a concept design done. It's not. The one I'm going to show you that I just recently completed with my son took us about 3 weeks to do. And we went over it and over it and over it and over it. And I'm only showing you the concept design. And you'll notice that the final design is different because as we went through our review of the concept, as we started building it, we found other cool things to do. And look, remember, this product is intended for use on your commercial renovation project. Make it something that has to do with what you've been working on. Okay, you have a site that you modeled and worked on, and then you did some interior design. Now you're going to do some manufactured design on it. The next one is super concept, visual, simple, primitives, but annotate how you plan to make it. I'm going to bend these. I'm going to weld this here. I'm going to bolt this together here. So it's all just a bunch of primitives, rectangles and cylinders and spheres and wedges. And probably not super right to scale yet. It's still just a concept, but you should be able to identify how something would be put together. Okay. And then clarify. Yeah, I'm going to do MIG welding because blah, blah, blah. Or I'm going to bolt these together because blah, blah, blah. Or I'm just going to use a bend. Okay. And then the last one is sort of show it in your model or how it might look. Now, if you did Revit, maybe you're not going to draw this and do it in Revit. And I'll have to show you how, if you did it in AutoCAD, you can put it in, or if you did it in Inventor. You can do this in Revit, by the way. It's just that I'm not really teaching how to do Revit families. But if you have done a little bit of work and already know, you're welcome to try to do this in Revit. I'm not going to teach it though. I'm going to stick with probably SketchUp, Inventor, and AutoCAD as we work through here. And today I'm going to work with SketchUp. Okay? But talk about, your spatial requirements. You'll see that in my sample, the spatial requirements were quite strong. I had to work with my son to really pack a lot of things into a small area. Organizationally, you're going to talk about, um, how you're going to organize your output. I've got my concept sketches, then I have my piece parts, and then I have my my dimensioned drawings that let me fabricate. Okay, so in this one, we're going to organize it just a little bit different. You're going to have your concept work, then you're going to have your scale model, and then you're going to have your your detailed drawings. Okay, and then of course you've got this one again. I really want to make sure that you get your discussion board done. And this isn't watched. You're sorry, that's the wrong terminology. You either did it or you didn't. Okay. Any questions on that part yet? Is that pretty much like we've been doing, right? This is the fourth time through, so hopefully it's sinking in a little bit, doing the same thing over and over. Okay, then let me show you just a sample. This is, I'll give you the background of it. This is something that my son built and he finished it last week. It's got a very specific requirement. As you can see, he's in recording arts, and this is a Korg MIDI machine. It's a full-size keyboard. Underneath here are this massive set of controls that allows him to basically do all of the MIDI work that he needs to do. Under here, you can't see it, but he's got a digital audio interface. He's got his simple recording microphone for when he's doing like very, very simple voice work. He's got a Mac that runs his Pro Tool mixing machine, mixing stuff. Down here, under here, he's got a Windows machine. He's also a drummer, so he has his music books down here. And he's got all of his keyboard. Actually, right now he's showing his standard keyboard and this keyboard, but he also has a third keyboard for when he's using his Mac, and he's got another keyboard. So he's got all this stuff, and he's got a recording studio in our house, but he's moving to Chico, and his recording studio and his living quarters have to shrink down to a 10-foot by 10-foot area. And so he designed a workstation that got as much organized into one little place as possible. And you can see he's got a lot of stuff in here. what's important is he always needs access to his keyboard. And so he wanted to make sure that he had that and that this was at the perfect keyboard height for, for him. This access to these keyboards, he can move around and do it. So he made this a lift-off piece. This is actually turns out to be 1 inch higher than he's got on his standard desk. And it's 2 inches farther away than what it's located on his standard desk. So he feels pretty good that he's got that down. By the way, you're not seeing it, but on the other side here, there's actually a hook for his headphones. But I made him get out of there so I could take a picture really quick. And these, he wanted to make sure that those could come off easily for mounting. So that's a double monitor stand that hooks onto the back of the wood. Now, the other thing is that he wanted to be able to carry this by himself if he had to. So each component had to be less than 50 pounds. But he also wanted it so that it could get upstairs, downstairs, through little hallways. So he wanted the top part to separate from the legs very easily. And that's where you'll see that we changed our design midstream. He had bolt-on legs that would come off, and it was pretty cool and it was pretty light. But then he figured out that he could just set this thing on top of here. So this thing, all of this came out of 1 sheet of plywood, by the way. Everything on here was out of 1 4x8 sheet of plywood, 3/4 inch thick. And we designed this in Inventor so that we could figure out loads and how much it would bend. So if he leans on this point right here and puts 50 pounds load on it, which is a lot, we found out that it would deflect unless we put a little support under there. So we added a support underneath in a spot where it doesn't interfere with the keyboard, and he can put 50 pounds on there and that will bend about 1/16 of an inch. And we tested it and it was right. So that's what I like about Inventor, but I'm going to show it to you in SketchUp. So did that give you an idea of what the design is and what it's for? Guys got any questions about stuff you see? What is that? What's this? What's that? You can see he's also, one thing that he did not put on here, by the way, which we were thinking of, is he is a drummer also. And so he was thinking about a little fold out Lazy Susan that would hold his drum practice pad. And he decided that that wasn't worth it. He could just stick it under there and move it out of the way when he sat down. So that's why you see the stick bag and the drumsticks, and the very, very edge of a drum practice pad. Okay, and you'll also see that he's pretty considerate. So there's an office right on the other side of this wall. There's actually another closet and an office. And although he practices with the drum pad, he put up a sound curtain so that basically there would be no sound going across to the office over there. So we appreciated that. That was pretty cool. So right here, so Brenda asks, is that a piece of wood and is it movable? Yes. And it's just a piece of wood. And when you pull it off, there's a cutout underneath it. And you'll see that in a minute. Well, let me just show it to you now. It looks like this. So there's a cutout, and this piece of wood you just pick up and take off. And we discussed making it so that it would slide or not slide, but we just figured that, it's not going anywhere. and it's real easy to just stick it on there. And so we just made it a little bit bigger so it just sits on there and it doesn't go anywhere. So yeah, did that oh shoot, just did the wrong thing. I hate it when I do that. I hope I get back to where I was. Well, I'll come back over to here. Um, so yeah, and it does. If he clears this area, he can just shove it back. But what he's found so far is um, this he's going to wireless on these. That it's just easier to turn around and drop it on his bed than to slide it out because you can't see it. But in a tent, this room is actually a little smaller than 10 by 10, and right behind him there's a bed. So he's come up with his best operating solution is to make that wireless and just pick it up and drop it behind him. So it's just very quick and very simple that way. So there we go. So there's a concept of a workstation that's really meant for a very specific purpose. So one of the things that you'll see is that we went through a bunch of work and we thought about how are we going to attach the legs. And of course, we were making it out of plywood because one, we have a saw, and two, Nico took a couple of years of woodworking in high school, and he's made a lot of his own furniture since. He's made another desk that he uses quite frequently. He's made this now. He's made some nightstands. He's made some specialized stuff for his, we call it his drum cave, but it's his recording studio. And so he likes woodworking. So we decided that this one would be wood. And you can see that to put these on, we didn't identify it, but these are bolt on from two directions. And this one was pretty fancy. It was bolt on from the top with a little plate screwed and bolted into here that it could bolt into for stability. And so to move this, then the original concept would be to unbolt the legs and then just carry this. But it turned out so much more useful to put a bookshelf under there. So it changed a little bit. Now, these pads right here don't actually exist, and neither does this little button. That was just for our inventor model where we could apply a load. So we were thinking, what if he put a 15-pound computer there and he leaned on it right there? So in Inventor, we were able to, after we did the concept work, we were able to do a little bit of more detailed design. And so very importantly, we were able to measure some key distances. His keyboard is 4 1/16 inch tall. So we had to make sure that we had a certain height available to us and that we had, and it does, it barely fits. And his keyboard is 54 3/4 wide. And so we set it up for 1/8 of an inch all around. And it does have 1/8 of an inch all around. And you can't really see it from this view, but in the back, there's some fairly large, this is an open area back here. So all the cords can come out and cooling. You can see that these are those two supports that we added in later on to give a little bit more stability out at these points. So this is the level of 2D documentation that I'm going to ask you to do. Just overall dimensions that show that it meets the need. Now, you might think that this 24 is a little too small. We actually measured his keyboard stand that he uses, and it's 24. So that was our driving requirement right there. And then we measured his keyboard height right now, and it was 29 and a half. And so that's where we drove the keyboard site. So we can actually point at certain aspects of this. We measured the keyboard and things like that. So yes, May, you can use Inventor, you can use SketchUp, you can use AutoCAD, or you can use Revit. And so the last piece of documentation is I want to see what your material looks like. So this shows the piece of plywood that we bought and where we would make our cuts to make sure that we had enough. And this was our cut list. So you're going to need to present something kind of sort of like this. This, of course, is week 3. This is week 3, and this is week 3. You're just all working toward that, working toward that, working toward that. And then I doubt if you'll get it made. Seriously doubt it. But if you can at least kind of show what it might look like when it's in use. This one was ideal because we got it done and I get to show it in use and it's meeting its intended use. Very, very happy with it. And by the way, I said it was birch. He actually found some maple. And this is the finish is just linseed oil on maple. Very, very nice. Very nice finish. So he's pretty happy with it. Okay, so that is what you've got. You've got program requirements. You've got that. I wanted to show you. So this is how you might build it in SketchUp. And I thought I'd just show you how I did it. I made a piece and then I made it into a group. So this is the bottom piece. I made it like 5 feet by 25 inches, whatever you decide. And I made it a piece. Well, let me just go ahead and I'm just going to do a new one. Save that one. So my first thing to do is move Google Person out of the way, just so, and I'll get rid of Google Person later. And I've got my concept sketches in mind. So I'm going to make this 5 feet by 2 feet, just for fun. And I'm going to make it out of 1/2 inch ply. There we go. So there's my base piece. And the trick, remember, when you're working in this is to make it a group. Okay, so I've made that a group. So now if I need to make that piece again a little bit higher, I can move it so the whole thing is up 5 inches. And now I know I wanted a little cutout out of the top. So if I had those dimensions, I could explode it and then I could go to the top view and I could actually make some sort of a cutout. Now I'm not measuring. You might do a little bit better job and make it right. Kind of cool. And then I'm going to make that a group again. So that I've got that as a group. So I'm just giving you sort of a process that you can go through. Because I'm thinking now in parts and how would I make those all one part? Oh, and then I might think about this one also. and say, oops, I really wanted that a little bit shorter. That'll do. There, now I can make that into a group. And I didn't get it all. You sure you get everything when you make it a group? There we go. And I'm still just kind of thinking about things, so I'm going to make this come partway out. I'll make it come out even with that, maybe. And I can press pull that because I've got it in my mind, this is all going to be made out of the same stuff, same piece of material. So now if I can make that into a group, then I can copy that over to the other side. See how by now, oops, I didn't do move. I didn't do copy. I did move. There we go. And let's say that's what I wanted to design. I'm just going to stop there for a moment. Okay. So now as I annotate this, I'd have to show how I want to build this. Now I'm going to think now about making this out of metal. And if I were to make this out of metal, I wouldn't make it 1/2 inch. I'd probably make it like 1/8 or 1/4 inch. And I'd do something else here. I would do another cool thing where I'm gonna start making the parts that I want to make. Watch this. I'm going to take that and I'm just going to copy it somewhere out over here. Get to where I can see it a little bit better. So now that's going to be a part for me, a single part. So I'd want to be talking about this part. And I could see now that I've got it taken apart that I could bend this. So if I were to explode this thing, get rid of that little line, now all of a sudden it looks more like a bent part that I could be, oh, I see, I'm gonna bend that there. And you could put a radius on there. I'm not so concerned about all of those details. I must not have gotten that right at the edge. Maybe I did. Well, if I need to, I can hide that line. So that copy didn't go so well. So I can't really quite get rid of that one. I might come back and make it a little bit better. But I could easily make a view of this and I could say, bend down. I could if I did SketchUp a little bit better. So I want to bend that down 90 degrees. So my next thing to do, which would be kind of cool, is to show how that might look before it's bent down. And I could even change this to bend that down 90 degrees each end. Now let me take this thing and copy it over here and see how I might do that. There, I think I have to look at it from the back. Well, I see what's wrong with this. It's truly not lined up quite right. Yeah, it's not quite lined up. Okay, but I'm going to rotate this thing and then I can move it. I'm not a super pro at SketchUp. Some people are better at this than I am. I want to move that corner to that corner. There we go. And then I want to do the same thing over here. There we go. And now when I look at it straight down, I see what that piece would be before I cut it out. That's my flat plate layout. Isn't that cool? And I could even put a note. There's that note again. Bend down 90 degrees each end. So now I'm thinking about how to make it. And when I talk about it over here, I might say MIG weld stitch 1/2 inch every 2. Cool. I mean, SketchUp actually does work pretty well. So Janice asks, can you use metal and combine it with another material like glass or annotate the glass part? Yes, so long as the glass is flat pane, that you can figure out how to attach it without doing anything special. Like, you know, if it'll sit within a couple of little brackets that hold it or something like that. But if you need to heat the glass and blow the glass or melt the glass in any way, no. But as an example, if you're making a display case and you want to show that the top surface is glass, you can do that. So there we go. So that's my little demo of SketchUp on, and look, all that make it simple. right? It's just rectangles. This whole thing is rectangles. Now, maybe for the legs, I want to make a cool bent piece and bolt it. I might even think of making a little bracket here that sticks up. I could actually bring a part out and bend it up and bolt it so that this is even lighter. And then I can start, if I was making this out of metal, I would probably put just a little bit of a bend somewhere underneath to stiffen this somehow. Because if this is metal, it's going to be really saggy, baggy. Okay, but if it's 1/8 inch metal and I put a bent lip on it, it gets really strong. So it depends on how much you know and how much you've done this kind of stuff as to what kind of design you would end up with. But that's how I would get going with it. Any questions on that? Oh, I forgot to show you. So this was one of the desks that was thought about. This was a desk that was thought about, right? I mean, that's got some kind of cool stuff. I know all this money off. Here's another one where he got the idea. Oh, I'm going to put the bookshelf on it. Um, Now, what ended up, and then there's also, if you look on here, there was one of the ideas where the piano was inside of it. And then there was this idea of putting the slider on it. Okay. And so look how, I mean, talk about beautiful construction style. Isn't that gorgeous? Um, and then when we saw this cutout, it was like, oh, that got us the idea of putting it up here instead of down here. But this cutout was so that he could pull it out and have all this stuff. But then this MIDI machine is really small instead of big. So those are the things that I want to see. This is what his audio interface looks like right here. That's almost exactly the one that he's got. Okay, so these would be part of the conceptual idea, and we decided against going with sliders. Just expensive. This whole thing you could buy for like $600, and Nico made his for $120 worth of material. So if you've got the ability to do that, here's another concept and idea of stuff. So look at all these cool concept ideas that he looked at all these and started drawing all these, and this was the one that really got him right here. Was he said, well, that's just a box. Why don't I just make that and stick it on top? That was a good idea. It was a really good idea. Now this really looks nice too, right? There's no doubt. One item. Make one item. So Leah asked, do we need to make only one item or multiple? One item. Cool. Any other good, cool? Yes, it can be whatever item you choose, so long as it falls within these parameters. Outdoor furniture, gazebo, fountain, storage, signage, awning, special lighting or sconce, ballard, special indoor furniture. Something that goes with your current design, intended for use on your commercial renovation project. So lots and lots to choose from, but you can't come and go, oh, I'm going to make I don't know, a shoe rack. unless the shoe rack goes with your intended commercial use. Cool? Which for some of you it does actually. Okay. Great, great, great work so far, everybody. Keep it up. I'm going to go ahead and turn off the recording now.